In this video, we're going to talk about rationalization of Z. So, when we're simplifying fractions containing Z at the denominator, it is usually more convenient to make the denominator rational so that you can avoid the division of decimals. Now, the process of making the denominator rational is what we call the rationalization. For example, if we have 1 on root A, right, how do we rationalize this? Now we do that by multiplying by root A. So that would be 1 root A times root A on root A. And when we do this, we should get root A on A. Very simple. Now let's take a real example. So let's say we have, we have 1 on 3. How do we do that? So we do this by just multiplying root 3 on root 3. And when we do that, we should get root 3 on 3. Very simple. Now, let's talk about rationalization said with binomial denominator, right? So when you are given a binomial denominator, how do we rationalize it? So given the said expression in the form of maybe A plus B, right? Then A minus root B is called its conjugate. So the conjugate of A plus root B is A minus B. So let's use a real number. So what is the conjugate of 2 root 5 minus 4 root 3? Just change the sign. So with this one, we are going to have 2 root 5 plus 4 root 3. That's the conjugate, right? So the product of a said expression and its conjugate is not a set. So let's say when we multiply A plus root B and its conjugate, which is A minus root B, we won't get the answer in the form of a set, right? So let's do it and see. So we have A times A, which is A squared. A times minus root B, which is A root B. B, which is root B times A, plus A root B. Then we have B, which is root B times negative root B. So that would be negative root B squared. And when we do it, we should get A squared minus B. Very simple. You can see that the answer that we got is not in the form of a set. Very simple. So, and one thing that you should also take notice, when we are rationalizing a fraction set whose denominator is of the form maybe P root A plus Q root B or A plus P root B, it is always important to just multiply both the numerator by the conjugate of the denominator. Let's take a real example of what I'm talking about here. So let's say I have a question in the form of maybe 1 on root 3 minus 1, right? So how do we do this? So what is the conjugate form of this denominator here, right? So we just multiply both the numerator and the denominator by the conjugate of the denominator. That's what we are talking about. So multiplying this, we have 1 on root 3 minus 1 times the conjugate, which is 3 plus 1 on root 3 plus 1. Then you multiply. So when you multiply, you should get root 3 plus 1 on 3 minus 1. You can go ahead and simplify it to get maybe root 3 plus 1 on 2. Then we have simplification. You get half root 3 plus 1 on 2. Right, so with that, you can see that we have A, we have P there, and we have our root B there. Right, so here, our A here should be half. A is half. That's how it works. So very, very simple. You can take another example. Maybe let's say we have 4 on, so let's say this example B, root 7 minus root 3. Multiply both the numerator and the denominator by the conjugate of the denominator. So we will have 4 multiplying root 7 plus root 3 on root 7 minus root 3, multiplying the conjugate, its conjugate. So that's root 7 plus root 3. And when you do it, you should get something 4 multiplying root 3 plus, so that's root 7 plus root 3 on 7 minus 3. That's what, when you do it, that's how you're supposed to get. So you can just calm down and try to do it on your own. You get something like this. So when you do it, you should get 4 multiplying root 7 plus root 3 on 4. Right, so this 4 down here will cancel the 4 on top here. Then lastly, you should get root 7 plus root 3. That's your final answer. It's something very simple. So this is the end of this video. I'll see you in my next video. Thank you for watching.